So it is recording now. Recording, and I'm going to share. And we can go to the Jupyter notebook here. All right, there we are. So you should be seeing the Jupyter notebook. So if you remember, we were, last Monday, we were going over the algorithm. As you can see, we've talked about the intuition. Remember, the intuition is basically, we are going to define now, we're taking what we had talked about with naive Bayes, with just calculating frequencies and determining a probability based on a frequency. And we've said, you know what, we're going to generalize it a little bit more. We're going to assume that a lot of things in nature follow a normal distribution. So for every x, right, which remember for every feature, f1, f2, right, so an x is made up of f1s, f2s, dot, 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 fn. So every feature vector. So basically you can think that for every feature, right, we're going to calculate a normal distribution, right? So we're going to calculate out of all the data, all the features in the data set, okay, what's the mean, the standard deviation, that represents, we model it as the bell curve or the Gaussian or however you call it. And then finally, whenever we get a new test sample, which is made up of a feature vector also of f1, f2, dot, 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 fn, whatever our features are, we are going to, compare these features, right? And pretty much try to determine if they belong to this distribution. What is the probability that that feature is very similar to that distribution? Is it like this area under the curve kind of thing, like that? Which, if area under the curve just means, in calculus, when you do an integral, for instance, it's just a calculation that says this little chunk, I'm going to calculate the area. Okay, and you can imagine how you can fit a rectangle here and then calculate that and make it tinier and tinier for it to have more precision. So ultimately, though, that's not very important for our purposes, given that we have a function. We're going to calculate the parameters. We're going to plug in a new sample into that function, and it's going to give us, just like before we would get out of counts, we would get frequency counts, we would get probabilities. Now we also get probabilities, but assuming a different type of distribution, the normal distribution, basically. So we can use the Gaussian function. And then once we have the values, remember, we had said that we would multiply the probability of class and then all the conditional probabilities of f1 given class times probability of f2 given class, because we will have already these probabilities from here, right? So this, the function that we define, f of x, and then, that function that I wrote the other day, e exponential something, and then, that whole thing. You can look up the notes. I don't want to really have to write it here again. Well, I guess I should for completion. It's 1 over sigma 2 pi exponential, and then you remember, and this is just a standard from statistics, so you have x minus mean squared, and then over 2 sigma squared. Like that. Okay, so that equation basically is what it's going to allow us to calculate this probability. So today we're going to take that approach. So this gives us, for our fi's of c, right? It's going to give us our data. So that means that we go over here, and now, we have these from that function. And then remember, we said that this is simply going to be, just like we described last week, frequency counts. However, we talked about that, this is a multiplication and becomes very, very tiny. So we're just going to do a little trick where instead of doing that, we're going to do log all the probabilities. Oops. log of the probabilities of F1C. And that allows us to, instead of multiply it, we can sum. So then it's going to be log of probability of F2C dot, dot, dot. And then, you know, the same thing, log of this probability. Oops. Okay, so those are just the little tricks. Remember, the log is just so that we can make very tiny numbers, that if we do something like 0.001 times 0.001, which I think this gives us 5 zeros in front of a 1, and they become too small, the log just allows for the numbers to become big, and then we can transition to, you know, a sum instead of a multiplication. But in terms of equivalency, we pretty much have the same. Okay, so that's just kind of to give you, again, to refresh your memory of what we were talking about on Tuesday. Everything I just said is exactly what I said before. And so now we're gonna the beauty about applied things like this is that I don't have to convince you, right? You can just believe the code, right? You can just believe the code. And the beauty about numpy is that numpy allows us to write very, very clean code. Very, you know, just a few lines of code will get us to where we want to go. All right, so now that I talked about this, we can go back to the code. Just remember, the last thing is that we create 3 little tables, right? We're going to create 3 little tables. Or I should say 2 matrices and a vector, right? So the simple one is this one. For the probability of C, we just have the 3 classes, right? So 0, 1, 2. And then we would have, so this is for class 0, the probability, probability, probability. We're just going to keep track of that information like that. Remember, that's just this little piece over here. And then to calculate these pieces, we are going to build these 2 tables, which these 2 tables are n classes by features and n classes by features. So if you think about iris, right? So it's always, although today I'm going to use more data. If you want to think of iris, you know, has 3 classes, right? So that's going to be setosa, virginica, and versicolor. I always forget that one. All right, and so that's for each class, we need to have a row. And that's the same here. And then we need, iris has 4 features, so we can just think of F1, F2, F3, F4, right? Fisher's iris has 4. So we are building basically this so that we can keep track. Remember that this one is going to be for the means. So we're going to take the means and, oops, that doesn't look like means. Maybe I should change to a different color. And then this one's going to be for the variances. Okay, I'm not going to, again, repeat, you know, the formulas for means and variances. Those were defined in the previous video, so you can just take a look at that one. Pretty standard. And then we need to calculate, right? So for the setosa class, because remember that we are doing probability of F1 given class, right? Given class. So given setosa, I need to know, you know, for that feature F1. Okay. So that to calculate that probability, I'm going to need the mean out of all the samples of setosa, right? And I'm going to need the mean. So remember, in the data set X, there's going to be, you know, let's say 150 samples, F1, F2, F3, F4, and I need to calculate for each column, right? Out of all the samples, I need to calculate the mean and the variance. And so that data is what's going to go in here. So I'm going to say, well, out of these 150, not all of them are setosa, right? So just maybe these, and that's it. Those are setosa. So I'm going to grab those, just the setosa ones, and I'm going to take their mean. Boom. done. Then I'm going to take for F2, and probably some, yeah, that it would actually be there. And so I would look at the F2 again, mean, boom, done. And I continue doing that, right? Then I'm going to do that for the means. Then I repeat the exercise, but this time around I do it for variance. So I grab same Setosa samples and I say, okay, I need now the variance for F1. Boom, there it goes. Do you see that? And then now, and I'm going to do that, of course, for all of them. And I have my data there. For each feature, I have the mean and the variance. And then I'm just going to look it up. Whenever I need a probability, to calculate a probability, as you will see, all you need is the mean and the variance, right? And then the actual sample that you're looking up. So we'll have all the parameters that we need to calculate. So we'll have the x, we'll have the mean, we'll have the variance. So it's really just going to be a very fancy lookup. That's really all we're going to do, right? In NumPy, so you can see how this should be pretty straightforward. Okay, so that's pretty much the idea. And then, I repeat this. Let's say now I'm in class versicolor. So versicolor happens to be the green ones, right? So these greens over here. So I grab those samples. Those are the versicolor samples. And for F1, I take the mean. Boom. Then, same thing for over here. For F2, take the mean. Got it. And I do that on the others and for all the other ones. So I'm in versicolor. So again, I grab for F2, the samples that belong to F2, that belong to versicolor and that are in F2, and I calculate the variance. There you go. And I plug it into my little table. Therefore, I have all the parameters that I will need, and then I can just look them up. Whenever I'm doing something, okay, is this class, is this sample, boom, this feature, done. Okay, and so that's what what we're gonna do today, but we're gonna write it in the code, hopefully get some data going, and that should, get us, closer. So I think with this naive Bayes algorithm, I will pretty much give you, I usually only want students to really, solve KNN on their own, right? It's gotta be the one that I'm not gonna require to solve all the algorithms. I'm pretty sure this naive Bayes one, I'm going to solve it completely, hopefully today. I think I have enough time. But it's still going to be homework, all right? It's going to be homework in the sense that I'm going to ask you to use it with like other data sets, right? Like I'm going to ask you to use it with Iris, for instance. I'll talk about that, but I already posted a couple of data sets, MNIS and Iris, online. And so I have a pretty good idea of what I'm going to require you for this third homework of naive Bayes, but the code will be a lot more finished. However, KNN, I still need you guys to finish it up, and we will discuss it probably, because it's due tonight, correct? It's due tonight? Guys?
I believe so.
Due tonight, right? Yeah, so submit it, and then we will discuss it next week after the exam, okay? If there's, so just I'll take a look at them. But I think actually the Dropbox or the link stays open until like Saturday, right? So you might want to double check. Can you guys hear me? I can barely hear.
Yeah, we can hear you.
Okay, so are there any questions? So I'm about to start the code. I'll try to wrap up naive Bayes. So before I do that, are there any questions? Remember, we have an exam Monday, right? You guys remember that?
Did we ever go over the exam?
Did we ever go over? Did I say that we have an exam? Did I?
I don't recall.
Really? I didn't say on Monday? Oh. I thought I asked you guys when you wanted to take it. Okay. I guess I do it with so many classes that it's possible. I didn't with you guys. So let's talk about that then. Sorry if I didn't. And we can push it back a week if you want. So let's see. Let me. All right. So exam 1, right? Usually I do exams on week 6, which week 6 would be next week, February 15th. However, I could push it back to February 22nd. Obviously, I'm going to move topics around, and the exam would include a little bit more content. So what is your preference?
I mean, depending on what the topics of the exam is, I think next week is fine. I just don't recall going over what is going to be on the exam.
It's everything we've covered since the beginning of the semester until, the class before the exam.
So just like look at the previous videos for like everything we've talked about.
Yeah, so it would be obviously, what is machine learning, the machine learning pipeline that we talked about, features, the vector space model, and KNN, the Euclidean distance, and naive Bayes, numpy, whatever we have done of numpy so far, doing the KNN algorithm in numpy, Bayes rule, and accuracy, right? So we've covered so far the metric of accuracy. I don't know that today I'll be able to get to this, but, and then there's a Gaussian function, the intuition of naive Bayes, just the intuition. And then, so you can expect about between 5 and 10 problems or questions, could be essay type questions, could be problems, explain, that kind of thing. So it's up to you guys. What is your preference? Do you want the exam February 15th or February 22nd?
Personally, I'd rather get it over with faster, so I'm fine with the 15th.
What about the rest of you?
Yeah, same. 15's good.
Same? Okay. All right. So the February, okay, great. So then the exam, that's all we will do on Monday. So it'll be obviously on Brightspace, right? You'll have to, come in for the first 5 minutes. I will post a type of Word document, and then you can just go ahead and answer the exam. If you want to write the answers in pen and pencil, you can, but then I guess you could take a picture. I've had students do that. They take a picture of what they did by hand and put it as a screenshot in the Word document. Make sense?
Yes.
Just make sure it's, of course, readable for me. So yeah, that would be the plan then. All right. Okay, it sounds like everyone is in agreement. Okay, good. So that's actually great because it doesn't mess up the schedule as I'm planning it. All right, so then let's go ahead and now, yeah, we're back here. Okay, great. So we're gonna try to, as I said, I'm trying to finish up this code. We're gonna make a few tweaks. Now that you understand, I hope, the intuition, right? I'm not going to assume Fisher's iris anymore, okay? So I'm not going to assume Fisher's iris. Just, keep that. If using iris, so just think of this as an example. If using iris, Fisher's iris data set. All right. Which, as I said, I do recommend. I posted it on the website. Take a look at that file, and then start just looking at them. Get a sense of these things: classes, features, etc. All right. So now let's do a few little things. So I have a couple of functions here that I'm defining, but we're going to extend our Jupyter Notebook to actually include a few more things. Okay. Now we want, just like, remember the last time I created the pipeline in a separate file and I said to you guys, have another file where you have the class for each algorithm, right? So that's usually what I would recommend that you do. However, in this example, I'm just going to write all the code here just to keep it pretty simple. So let's do that. So I'm going to need for this a couple of things. One of the things I'm going to need is from sklearn, I'm going to use just the same thing we used last week or Tuesday, I think, Monday. From sklearn import datasets again. So this is a very convenient way for me to have some datasets, and we're going to create a dataset for this problem. All right, just a simple one. Another thing we'll need, since we're going to create a dataset, is the split function. So I'm just going to do from sklearn dot model underscore selection. I'm going to import train test split. So it's the same thing I did on Tuesday. Because these are the kinds of things that after a while they get repetitive, right? So it's really great because you guys, that's how you start to see the patterns. This is just 2021. All right, so we have our libraries there, our module. Sorry, I'm a little bit obsessive compulsive about this. Okay, so now I have the libraries there. And at some point, we might need the accuracy function. Remember that I've already defined somewhere else. We can always bring it in here. But the first thing I want to do is, since this is a little bit better understood with the data, right, I'm going to just want to have a little bit of data here. Okay, so I'm going to create pretty standard, just like homework number 1, my x, comma, y, right? That just means my data and my feature vectors, so a whole bunch of samples of feature vectors, and then their corresponding labels, they're going to be aligned. So I'm going to generate these kind of randomly. So I'm going to use data sets, which is the thing I have, or data set, the thing that I have above there. Oh, it's called data sets, by the way. Yeah. I'm going to do data sets, and I'm going to create some data. So I'm just going to say make, and you can, going forward, you should always do things like this, run iris, run mnis, plus create some fake data, and just, test your algorithms, right? So going forward, that's our plan. So you can definitely take a lot of this and add it into your KNN implementation, okay? So remember that, this is what I want you guys is actually what you should do if you haven't done so already. Create a GitHub, your own account, and have your own, like, my machine learning algorithms, and start loading these, because whenever you do this kind of work now, you can always just get your own code, look it up when you're thinking about things, and you already have it. So you're creating, it's like a toolbox, right? We have a toolbox. It's kind of empty right now, but we're trying to fill it up with all these techniques. Okay, so then you're going to do my classification. All right. And you can see that there, my classification. Now we just need to define a few parameters. So I'm going to do n samples. And you could do 150 if you'd like iris, right? Just kind of create that. Or you can say 1,000. And then n features. You could say, well, I want, oops. So you do features there, and you could do, well, 4, that's iris. You could do 10, like mnis. It's up to you, right? So you can play with it. N classes, you can do 2, 3. Let's just do 2. Okay, 2 classes. But as I said, definitely play with these parameters. Build it to look like mnis. Build it to look like iris. Try other things. And then random state is just like a seed that you provide. So that the randomization has some parameter to start with. So here we're just going to say, 1, 2, 3, some number. And again, play with that number as well. All right, that one line of code pretty much takes care of what we want. So hopefully if this worked out, I'm going to comment out a lot of this because it's incomplete. And I just want to test that the code works. I hate that this Jupyter does this. There we go. All right, so I commented out everything that's incomplete. Hopefully this will run. Let me save it. Okay, that's good, right? So it ran. That means, you know, we have our data. That's the first thing. That's really great. So you can try, you know, this is like we talked about in the numpy example previously. You know, you can run this one. Okay. Oh, there it is. Just a little slow. So there's your data, right? You have some data in there. You know what? I'm gonna do just 4 classes because you know it always does. I don't like it when it, you know, you can't really see it clearly. So yeah, let's go back here. I'm just gonna do 4. Okay. Oh yeah, so that's a little bit better. Save it, run, and there you go. So now you have your matrix data there. We have 150 samples and we have 4 features. Okay, just like we were doing before. So we can start to process this really well. We can also do this for the y. So I can do print, you know, y, the y vector, which is this one over here. And let's just see what happens. So if I run, and you can see it's a vector of 2 classes, 0 and 1. So basically, you have a little data set there, and now you can perform some machine learning to test your algorithm, okay? This is pretty much what we've done a couple of times already, so hopefully by now, this is making sense. So I'm going to go and, you know, I just, you know, I don't want this there. I want that there. So I'm going to clean this up. Okay. And so I have my code back again here. So now the next thing I want to do, obviously, if I'm going to do train and test, because, you know, I'm going to need that accuracy function that we defined on Monday, I'm going to need to do the split, right? So, but that's, you know, it's the beauty of this. It's so elegant, right? You just do X train, X test, Y train, Y test. Y test, you do those 4, and now you just call a function train test split that we already defined over here. So I'm going to do train underscore test underscore split. Okay, and then, you know, we do that, and then of course the same thing. We're going to plug in our x comma y in there, x comma y. Later on, you know, keep in mind, if you had a text file, so you might be thinking, what if I had like my own text data that I collected in a text file? Well, we'll see later that it's just one line of code, basically, using some library like pandas or numpy. We can bring in all the data from the text file into our x and y. Exactly the same thing, okay? So you'll see that's, you know, pretty easy, so I wouldn't worry about that at all. But for now, we're more concerned because this is machine learning foundations, not so much applied machine learning. We're more concerned with understanding the fundamentals, right? And so we got to understand these 4 classes in supervised learning, these 4 classes of algorithms, the KNN, naive Bayes, decision trees, and then all of the logistic regression to perceptron and neural nets, deep neural nets. That's one family, all of them together. Okay, so let's go ahead and we have x and y here. That's done. Then we need to define the test size, right? So the test size, oops. No, actually, that should be test size and it's just going to be equal to 0.3. I always do this because when I think of iris, I always think 120 and 30, right? So I think that's a 70% split, or is that an 80% split? I actually don't know. Well, it doesn't matter. Think about it. And then, again, some kind of a random state for it, because the samples don't just get split in order, they're randomized, right? Because, you don't know how the data was collected. So all the rows in your X matrix are like jumbled around, not the columns. The columns stay exactly as they should, but the rows get moved around, randomized. And then, and then that just provides for a better machine learning. So I'm going to do state equal, 1, 2, 3. Again, they don't have to match, but it's just some number. All right, so now that I've done this, I've got my data sets, right? And so I'm ready. At this point, I would be ready to start, obviously, calling train, and predict, and the Gaussian and everything. So the first thing is, I'm actually going to move the comment here, down here. Keeps doing this weird thing. Let me get, so now it's going to be, so I've commented out these two. I've got my data set now. And the first thing I probably want to do is I'm going to call train. Right? So train does something with the model, right? So train, and what would we train on? We would train on X train, comma, Y train. Right? We would look at the data and the samples, the labels, and we would train on them. But we haven't finished the function train. So that's where we need to go now. Again, remember, we need to do that, build that model so that we can do predictions. Okay, so now that we have our data, we can switch over to bit, or train, sorry. So let's dive into the train function. Okay, so if you think about it, train over here already takes X train and Y train, which are these parameters, so we're passing good. Now we are going to look at what we were doing. So we would get X and N samples and N features, and I am actually using 150 and 4, right? This, maybe change it to 3. So 3 classes so that it is in fact consistent with iris. So you can see here, N samples is 100 and, I'm splitting on 0.3, right? So 150 times 70 is 105. So it's actually 80 then. 150 times 0.80, that's 120. Okay, so this should be 0.20. So it's an 80-20% split. 80% of the data will go to train and 20% of the data will go to testing. So then this would be correct. So 120 samples, N features is 4, yes, right? And we get that from X shape, okay? Then we do list of classes. So we just need to look at, we're going to use 3 classes. So that would give us 0, 1, and 2, most likely. And then we're going to do N classes, list of classes. So what I'm going to do is actually, I'm just going to comment out all of these. And that way we can get a feel for what the data looks like. I'm already calling the function, right? So we're just going to have print statements here all the way. And this is a good way of getting a feel for your data. So I'm going to do print N samples. See that? So that's everything that's happening in this function. So let's go ahead and run that. I'm going to save it. Okay, and run. Okay. Oh, okay. You see the error? I see the error. Okay. X train, so they should match in name. All right, let's try that again. Okay, I'm going to run it. Huh. Where is it giving me the error? Let me see. I think it's actually there. Yeah, so it's not even in the shape. It's in here. Takes X and Y, test size. Okay. Why is this? Give me a sec. Let me think about this because this should not be. It says here, n classes times must be smaller or equal to 2n4.
When I made my classes smaller, the N classes, it worked.
It works, so you just made it 2? Yeah, I was thinking
Yeah.
that. It doesn't like 3. It might just be a binary thing. You know what I mean? So let's see. Okay, so this time, yeah. I think it's this function that I picked, make classification. I'll have to look it up, but it might be that it only likes binary data. That means 2 classes, and since I had 3, so I'm guessing that would be the issue. So let's see now. I'll have to kind of like double check. I'm sure there's one for multi-class, but let's see this. So now it should print out the dimensions of X, which are 150 by 4. Okay. Yeah, sorry, 120. All right, so it worked, right? You guys see that? So this doesn't affect us really. If we want to for whatever reason, it's only liking 2 class. I'll take a look to see another function that can, or you guys can look it up, but we should be able to continue. All right, so that gives us the number of samples, which is correctly 120. It also gives us the number of features, right? So that should be 4. So that hopefully will work. Okay, run it. And there it is, 4. Okay, so we're back in business. All right, so that's good. So now, let me just grab some coffee. be here. All right, so next thing we want to take a look at is we know that this works, right? So we can just get rid of that. And then now let's do the list of classes, right? So this is the next one. So intuitively, this should give us 0 and 1, right? Not 2 because it's only, and then, yeah, that has been the problem. So I'm going to print this out as list of classes. Okay, that should be a type of a numpy array with 2 values in it. So let's clear it. Okay, run it. And there you go. You have a list. That way you can iterate through the classes. You know, the trick here is that you might want to iterate through the classes. So that's good too. So we can get rid of that. We understand what's in there. And then this one is the number of classes. Now the n, you know, that's just the length of this. So that should be 2 classes here. I'm going to take that out. And print n class. Okay. So I'm going to clean this up. Run it. And there you go. You got 2 classes, right? 0 and 1. Now, the next thing is we want to calculate the mean variances for the Gaussian and the priority probability for the classes. Okay, so let's look at this one first. Priority, that's just a numpy zeros class, which is going to be of size and classes, right? So 2. And remember, we need to have 2 cells in there to store the frequency counts for each class. So I'm going to save this, do the same thing. Okay. Run it. What happened? Oh, I didn't print it, so I have to print priority. Okay, so now I'm gonna print it, and there you go. See that? I have my 2 placeholders there for the frequency counts that I'm going to have for each class, for each of the 2 classes. So that one works. The next thing we want to look at is the means, right? So the means is going to be, so if you remember, that's just, if I go back to the note, the whiteboard, it's these, right? So I just printed just now this one, although it only has 2 for the PC. Remember that PC is this component here, frequency count. And now I need to calculate these probabilities. I'm going to need basically these little tables, right? So I'm going to print out right now the means table for the 2 classes and 4 features, right? So it's going to be 2 by 4. So if we go back to, and then later it's going to be the variance for 2 by 4 as well. So now I can go back here and I'm going to print out the means. So it's NP zeros of n classes, which is 2, by n features, which is 4, and it's just going to be currently set to zeros. No calculation has taken place yet, but we can run it and you can see it there, right? So 2 classes, 4. And for each one of these, this is going to be the mean for class 1 of feature 1. This is going to be the mean for class 1 of feature 2, and so on. So that later we can just look up these values pretty straightforwardly. All right, so that's done. the means works, and then now we can activate the variances, and that's the same thing. It's 2 by 4. So this just print it there. This. Okay, same thing. Run it, and you can see it pretty much looks the same. But now we have our two, matrices where we can store our data. Okay, so this is basically, we can get rid of this now. This is where we left off on Monday, and we can pick up here, although we have a lot more tools now. So the next step that we want to do is we want to calculate the values, right? Calculate the values. So numpy is so elegant in these kinds of things. So all we have to do is for idx, comma, and idx just means index, right? Index of x and c, right? So we're going to get a tuple by using a function called enumerate. So we're going to say for tuple idxc in enumerate. And what do we enumerate? We're going to enumerate the list of classes. Okay, so we can just plug in there list of classes. List of, or numpy array of classes, right? But it's called list of classes. We are going to basically iterate through it. So that means we grab the first one. We'll grab whatever class is in there. If you guys remember, it had class 0 and 1 when we printed it, right? And it's actually written here. So in the first iteration, we grab 0 and the index, which is 0, and then we grab class 1 and the index, which is 1. But keep in mind that it could be values could have been -1 and 1, and then index 0 and 1. So just keep track of that. A lot of machine learning is sometimes, NumPy in particular, is about those little keeping track of that. So now if we just want to be, you could print this out. I encourage you to print this out on your own, like print, IDX and then print C, and you will see basically the result. So for instance, if I run it, you can see there 0, 0, 1, 1, right? So it's printing them as we would expect. But what we want to do really is we want to do some calculations. So here we have another trick. We are going to populate every single one of these, right? So every time we need to extract from the X data, from X train, right? We will need to extract just the samples related to the given class, right? So first we're going to do this for class 0 in the first iteration. Then we're going to do this for class 1 in the second iteration. So here I'm just going to say then, I'm going to create something called XC, where XC is the same X train matrix. So it's still going to be X train, but sort of filtered. So I'm going to take X train and I'm going to filter out the classes that are not the current class. Okay, and then that way I'm just going to take those samples and pass them on here. So for instance, and to do that is pretty easy. It's a type of slicing, right? It's a type of slicing that I think we looked at before, where I say, I just want the indices. Oh yeah, we did this when we did the accuracy. I'm going to compare two matrices. I'm going to compare matrix Y train with the value C. You see that? So what this means is that, if I go to the whiteboard over here, go to the whiteboard, what I'm going to do is I have my Y vector and I have C, in this case 0. So you know that this, we already looked at it, look like this, right? So what this is going to do is it's going to say, oh, this is a 0, this is a 0, this is a 0, this is a 0. Therefore, 0, 1, 2, 3, 4, 5, 6. So the indices that I want are, so the result of this operation is that it's going to give me the list of indices in question. 0, 1, 4, 6. Do you guys see that? These are the indices. And by having those indices that match the value in y to be 0 for that 0 class, I can now filter out the corresponding x's. Because x, what I want is f1, f2, f3, f4, you know, but just for the vectors that correspond to class 0 in the first iteration. That way, now I have all the vectors that belong to class 0, and then I can do the mean and the variance just for those. And then when I do class 1, you know, the next iteration, I'll repeat the same, but this time around with the ones. So it would give me the indices. So these are the indices for class 0, and then these would be the indices for class 1. So it would be 2, 3, and 5. And then that way I go into X, slice those out, and I'm just going to grab this vector, that vector, and this vector. And out of those, for each feature, I'll take the mean and the variance. This is probably like one of the hardest things in this whole thing, right? So if you understand that, you're good to go. And you can see it's just a numpy trick. Is that clear, guys? Are there any questions about what I just said?
I think the idea makes sense.
Okay, great, excellent. All right, and you can always, you know, I recommend that you just play with this, you know, play with the code before you submit your assignment. All right, so now that that is discussed, we can go back to the code over here. All right. So we are right there, right? So we just slice the data for the corresponding class. So we have for class C 0, the current one in the current iteration, we have our XC, all of our data in there. Okay, great. Now I need the mean, right? So I need the mean, which is going to be this thing that I just created, which was 2 by 4. I need to populate it with the corresponding values as we have discussed. So basically what you can say here is, you can specify, you can say, first of all, it's going to be for index 0, right? The first index. So that's going to be the first row of means. Okay, so we want to plug in this value, or we want to basically say with this value, it's row 1. In the second iteration, we will say, okay, by the way, these values go in row 2, and so on. Okay. So again, you know, if I go what I had drawn over here, it just means right now we are focused on, let's say, the first one. Okay, and I'm going to plug in the values there for the mean, and then I'm going to repeat that for the variance. When the for loop goes to the second iteration, index IDX will be 1, right? Because this is 0, 1. And so then it's going to grab the next one. So now I go back over here. Okay, and here I can just say for grab index 0 and plug in for all, basically, all columns. So it's going to be all 4. So then now over here, I can do what I need to do. I need to grab for XC. XC is this one, right? Just the samples that belong to that given class, right? Out of the 120, maybe there's like 30 or 50, I don't know. But it's 50 by 4, 50 by 4, because those belong to class 0. And then the rest, the other one, 70, for instance, is going to be, when we do class 1, it might be 70 by 4. Okay? So just think about that. So now I need to grab these XC, and I need to do dot mean. as you can see, we don't even have to specify, we don't really even have to specify the equation itself. We just call the mean function. One last thing that's very useful when you use NumPy, TensorFlow, PyTorch is something called the axis parameter. And the axis parameter just allows you to decide, okay, if I'm applying the mean on something like XC, should I apply means, you know, the mean of every row? So I look at every row, all the values there, and take the mean of that, or do I take the mean of all the columns in X, right? And that's what the axis C is for, okay? Axis C is for. So here we can see, for instance, that this gives us, and that's it. That pretty much gives you the values. So now let's go ahead and kind of just print out, we would do just for means. Print out this, and let's take a look at what means contains. So obviously means initially is zeros, but once we've completed this task, there should be some data in there. So let me save it, clear. Okay, and now let's run it. And there you go. So as you can see, for what this is that for class 0, the first row, I've got for the 4 features, F1, F2, F3, and 4. I looked at all the samples given the class, given the feature, and I got the mean. It's a pretty elegant solution. So I got my means now. Now let's go ahead and let's say that I changed that parameter. Let's just play with this a little bit. I changed this axis to 1. All right, and save it, clear it. Okay, go ahead and run it. And could not broadcast input array of shape 61 into shape 4. So it doesn't quite like it. All right, to do that, because the problem was it did this, no problem. But the problem was it couldn't fit the data into this, right? That couldn't happen. So without getting into too much, I don't want to waste too much time, but because these things you should try out on your own. But just really quickly for completion, let me do, I'll leave this as 0. That will be correct. But let's just print this one. And change it to 1. So that should not be an issue. Save it, clear, and run. And you can see this time around, it averaged row-wise, and that's why it's just 1 vector, probably of size, I don't know, whatever it is. Okay, pretty exciting. Okay, so now we've got our means. I think if you understand means, you should understand variances just the same, given that it's exactly the same thing. So I'm just going to say variances, same thing. You know, now it's going to be the, you know, same IDX, because you have to do it for each one. So we're still in class 0 for all 4 columns. And then I'm going to do the same thing, X underscore C, but this time I'm going to do var, and var is the variance. And then I can do this one over here, and then I can do axis across the 0 axis. So I want to do column-wise. What I always do to remember these is I just, you know, what I did just now. Okay, with 0, it looks like this one. Okay, I know which one, because I sometimes forget. All right, and then the last part of this is the priorities. And that's just the frequencies, if you remember. So for this one, we don't need, remember, it just had IDX, right? Priority is just a vector of 2. So then we just need IDX, and then we're just going to say X again for only samples that belong to that class XC. right? We need to calculate the frequency, And what is the frequency of that? It's super easy, right? It's exactly what we discussed last week. So if I go to the whiteboard again, okay, and let me move to a new one. So we have X, and then we have XC. And XC, we do that trick, and it becomes a smaller thing, right? So maybe there's like 1 to 10, and then there's 1 to 7. So this has 1 to 17, right? So if we want all the samples for that class, all we have to do is take 17 divided by the total here, which this should be 120. So that gives me the frequency. When we do it for the second class, well, it would be the difference, right? So it'll be, you know, whatever is 120 minus 17 divided by 120. And that will give us our probabilities for class 1, probability for class 2, which are just basically, we're not worrying about a normal distribution here, Gaussian or anything like that. We're only waiting we're only waiting for we don't want to worry, let's say, about the normal distribution. We only want to worry about the frequency count. Okay, so to do that very straightforwardly, then we can go over here, and now we can say probability XC. We just need the size of XC, right? So that can just be shape. It's a matrix of rows and columns. So we need the first shape in this case, which will be shape 0. So that dimension. You guys see that? So it would be, because it's in our previous example, it would be 17 by 4. XC would be 17 by 4, let's say. So we need just this one, and then divide this by the total number of samples, which would be, do we have that? Yeah, we do. We have n samples over here, right? So then we can say float, just so that we make sure that it's a float, n samples. And there you go. And that, believe it or not, that's it. I mean, you are at that point. You've calculated the data, right? You have your train, if you will, done beautifully. Okay, so let's just run all of this, make sure it doesn't break. So I'm going to go ahead here and save it, and I'm going to clear the cache, clear the kernel. All right, and now run it, and I'm not seeing any errors. So basically, you calculated all the details that you needed. Now we can focus then on the next function, which is going to be predict. But we still need to calculate. So if you think about it, what do we have? Let's kind of go there. What do we have? If we go back to the original formula, we already have these, right? So this is already there. And we have the parameters for these. We just haven't calculated the probability, because to calculate that probability, we need to look at the equation, right? The Gaussian. So we need to write a function just that if we give it these parameters, right, we get what we need. And so that's the next part, the last part of this. Okay, so I'm going to switch over to the code. All right, and now I need to focus, let's say, on predict here. And then we'll come back. We'll motivate the Gaussian, but we need to predict. Any questions so far, guys? Questions? You guys hear me?
No questions.
All right, good. All right, so now let's go ahead then and let's take out that. So we're going to predict. Okay, so what do we need to predict? Well, we would need a test sample, something, X, right? This one, let's call it, or we actually have some test data, right? We have X test and Y test. So actually, that works out really well. Let's call the function predict. And remember that predict will probably return something, but let's just leave it like that for now. So predict would take X, oops, we take X test, which we have our data right there. We have, you know, whatever the number of samples, 30, I think, left. So then this will take X test. Okay, X test, so that's settled. Now what we need to do is we need to let's actually do predict, two predict functions. One that just predicts for an individual sample, and then one that predicts for multiple samples. So that way, we'll keep this a little bit more straightforward. So let's say then predict set. Let's call it predict set. That means that we can take a huge sample of data, right? And then we're going to have a second one that just predicts individually. So let's just call that one predict. So this one would only take one sample, X, lowercase x. Okay, and I don't have any, okay, let's say X, one sample, right? Just to be overly explicit. So then here in predict set, which is the one that we are calling over here, we can say, well, I'm going to iterate through all the samples and look at the data. So we're going to use a list comprehension. And I'm going to say for X in X test, right? And that way, if I have 30 samples in here. So it's 30 by 4. Every iteration in the for loop will grab one vector. So it'll grab like row 0 and the 4 columns, and then it'll grab row 1 and the 4 columns, and then row 2 and the 4 columns. So I'm slicing out the vectors by doing this. So that way I can just give it one sample, and then I give one sample to my predict function, the one that I have at the bottom there. And the parameter, obviously, that I pass to it is X. So that's just a list comprehension. So this little value goes in here. So obviously, then, this will return a vector of predicted classes, which is quite convenient, actually. I'm going to have 30 samples. So this list comprehension should return 30, a vector of 30 predicted values. Okay, and we can call that ypred vector, let's say, right? So then later when you guys look at your accuracy, you will compare this vector to what? To Y test, because this one has 30 labels, the real ones. This one has 30 labels, the predicted ones. Okay? So that's an important element. So this function is quite straightforward. You just have to return that vector. Just make sure that it is a numpy array and not just a list. The list comprehension, remember, it creates just a list. So we can just say numpy array, np array, and then the value that we plug in here is ypred vector. It has to be a numpy array because this one is going to be a numpy array, and that way it'll make everything more straightforward. So you don't compare a numpy array to just a regular list. Okay, you probably don't want to do that. Okay, so I think we're still doing good on time. so that completes this function, right? Y predict predict set, sorry. So this one would return, let's say that vector. So outside we can just call it, you know, result Y pred. I usually just like to call it Y pred, like that. And then comes your accuracy. I'll leave this to you guys to figure out, but it was basically, you know, accuracy. You have to obviously import that function for it to work. And then remember, it would take Y test, this one, and Y pred, comma Y pred, like that. But I'll comment this one out because I don't have it in yet. Just copy the function, plug it in there somewhere. All right, so a lot of the pipeline is in pretty good shape now, except that, so what is this predict function, right? So we still need to do this predict function using the data that we have, the data in means, variances, and so on. Okay, so usually this is where writing this as a class would be very handy, okay, very handy, because then the means and the variances are accessible to the entire object, okay? So just keep that in mind, that for convenience, we'll probably change it to a class so that we don't, because otherwise what you're gonna have to do, it's not terribly difficult, but train would have to return means, variances, and priori, okay? So that's how I'm probably gonna do it now, but you would probably want to do this as a, you know, as object oriented. It'll just make it more elegant. All right, so anyway, we need that information. So now let's go to predict, the actual predict little function that only takes one test sample. Okay, so this one just takes one test sample, which is x one sample. So here, what are we gonna do? We need, this is going to be, again, we need to go to the notepad or this one, whiteboard, and we need to look at this equation, right? This is the equation that we want. We already have this. This is in priori. We just need these. And these are going to be several, right? So there's going to be, for our example, there's going to be 1, 2, 3, 4, actually, because we have 4 features. And so it's going to end up looking like this, right? And we can create a vector probably that will store these values. And we're going to call it, you know, if this is priori, we can call these posteriors, okay? Just that, or we're going to create a vector called posteriors where we're going to store these, okay? That we're going to store each one of these in there, and then we're going to apply log and sum them. That's basically what we're going to do. So if I go back to the Jupyter notebook, you can see that I'm about to do that. So let's call it posteriors probabilities. It's just basically like a little list for now where we're going to store the values. And now we can say we need to calculate the posterior probabilities, okay, for each class and select most likely class. Remember that at the end of the day, we do the posterior for each of the 2 classes, and whichever one has the highest likelihood is the one that gets selected. All right, so now what we need to do is we're going to do for, same thing, IDX, same trick, C, okay, in enumerate. Now, what do we enumerate through? We're going to need, again, the classes, the list of classes. So keep in mind, this is where this gets complex, right? Now we also need this parameter, right? And because, you know, this has not been object oriented, you know, we need to basically return all of these parameters. So I'm just gonna go over this algorithm right now, then we'll fix that. But assume that we have access to all these things that we computed just by returning them back. So we would do return, and then we need, you know, like global things like you know, list of classes. So as you can see, this is where this kind of motivates the fact that we should probably use object oriented. It'll just make our code better. Variances and priori. Okay, so hopefully that's all we need. We'll come back to that. So I'm going to copy these. So now train would return all of those, right? So then train here would provide that. And then now we can plug in predict set. Notice how much we have to do, right? We have to now carry these in here. So it's not great. And then these have to also be carried into here. Wow, and then they also have to be carried in here. You can see that. So it's quite a bit. So one of the things I want you to do for the homework is I'm going to ask you guys to change all of this to object oriented, okay? Let's create a class and everything. It'll just make your life easier. Then here also, we got to plug it. See how, you know, that's a lot. And now we have it, right? So now we can enumerate through list of classes, okay? So we can enumerate through that one. All right, and so this is exactly like what we did before, if you think about it in train, right? So we did IDXC in enumerate list of classes. And now we're just doing this again. So what's going to happen is we have two classes in here, so there's going to be two iterations. The first iteration, IDX is index 0, class is 0. All right, good. So we're going to then just grab that first row, right? Just that first row of the variances, of the means, and of the priorities, right? And we're going to need those parameters to calculate our probability, the probability, this one, which is sometimes also called the probability density function, or PDF, right? But we're just going to call it probability density function, or PDF. So we're just going to use that one. And so let's call it Gaussian, basically. So here I'm going to, I need now, I got the class by the index, right? So the first thing I need to do is the prior. So the priori was the list, the prior will be just one. So if I go to my whiteboard over here, I'm going to grab this one, right? So just this one for that class, okay? Okay, guys? So I'm going to grab that one. Okay, so that's going to be, that should be what? It's going to be from my priori, right? From my priori, which is this one, should be that one. I'm going to grab just a corresponding, oops, priori. Notice this is priori and this is prior. So I'm just going to grab the first index, IDX. Okay, I grab that value, that frequency, I've got it now. Okay, just for that given class. Now remember that we said that we don't actually multiply like this one, but instead each one gets passed through a log function. So it's gonna be probability of C, and we plug that into a log, and then we're gonna add the values, right? So we're gonna end up, for this example, with 5 of these. these for the 4 features, which are based on the PDF, the Gaussian, and then the 5th one, which is just based on the frequency, but they all go through log. Okay, so that's what we need to do over here. I'm going to go ahead. I've got this one, priori IDX, and now I can just simply say np.log. See how simple that is? And so, oops, sorry. So I got that parameter. I just need the other 4 now. I need the other 4. So those are going to be the posteriors. So let's say I need, I have to think about this. I'm going to add each one. I need to, so let me think about this. This is where I need, the next step would be to calculate the Gaussian, right? So now I need to calculate these. Each one of these needs to be calculated and added, okay? So to do that, I'm going to take, these are the posteriors, so let's call each one just a posterior, not plural. Okay, I grab one. And I need to calculate okay, so I would need here the X1 sample. X1 sample, right? I need that. I'm probably going to need the means variances. I don't need the priori anymore, but I do need these. So I need these 3 parameters. And this is where I'm going to call my Gaussian function that I need to define now because I need to calculate that probability. So I'm going to say Gaussian like that. All right, this should be invoking basically this. So I'm currently just invoking one of these without the log, without summing it, just invoking this one and running it through this equation. So for that, I need the X1 sample plus the corresponding mean plus the variances. Yeah, so let's go ahead and do that one. So in the Gaussian, then, I need to pass these 3 parameters. Okay, so now I'm going to take this out here. All right, and now I've got to figure this one out. Okay, I got to think about what else I need. You know what else I need? I need the class, right? I need to know which class I'm currently processing. So just like we did IDX here, so I need to pass IDX here. Okay, because I need to know, I got all the means and variances in these little tables, but I need to know which row I need to look at. Do I look at the means for class 0 or do I look at the means for class 1? And then do I look at the means for the variances for class 0 or do I look at the variances for class 1, right? So I need to do that. So hopefully that should be enough. So in this function, then I need to now calculate, what do I need to calculate? I need, so let's take a look at, so I just need to do the equation, okay? I just need to do the equation. So now I have to look at this one, all right? I have to look at this equation that you're seeing in the whiteboard. So the exponential is usually the E. So let's, this part here, x minus mu square divided by 2 times the variance, because the variance is sigma square, and that's all e to that, right? So e to that. So that can be the numerator. And then the denominator then should just be the variance times the square root of 2 pi. Yeah, so we can break this up into numerator and denominator and then just do the calculation. So let's go ahead and do that one. So I'm going to do here, what I want is return, return numerator divided by denominator. So divided by denominator. All right, so, and now I just need to define those. So that should be pretty nice. So numerator is equal to something. Denominator, okay, is going to be equal to something. And that's just based on the terms, right? So we have already variances and means there. So we need now keep in mind that one of the, now this is where I'm going to do a bit of trickery. Okay, so instead of thinking about this like individually and calculating this one first and then calculating this one, and then because we're using numpy and everything is a matrix and a vector, and this will become a little bit more obvious when we start doing the multiplications in numpy, we can actually do a multiplication on an entire vector. Like we can apply, like I can, instead of just doing this and then doing it, I can do the same operation to all 4 in a vector, okay? So just keep that in mind. So that's what I'm about to do here. So for the numerator, I'm going to say, it should be here. The numerator is the exponential, right? So it's numpy dot exponential, and then we've got the parameters that go in it, right? So we've got the parameters that go in it. So it should be, if you can at this point just look at the equation, it's going to be x, 1 sample. Not, you know, so it's not too big. I'm just going to call it x here. XS maybe. All right, and then XS minus means. You see that? Minus means. But I need to say which row, right? And so it's going to be IDX. Just keep in mind, this is still a vector, all right? So I'm applying this value, this one, to the vector basically. So this is a vector of 4, and this is also the means, right? So it's a vector f1, f2, f3, f4, and then means here is also f1, f2, f3, f4, but the means themselves. So I'm comparing all at once instead of doing them individually. Therefore, this operation should return a vector of also of 1 by 4. Now so now I'm going to put this in parentheses here, and then that is squared. So you can just do that to square something. And then there's a symbol there, a minus, a negative that goes in front. And all of this should be, I'm going to put this in parentheses. Oops, don't do that. All right, and then this is divided by the variance, right? So it's going to be 2 times variances. But again, I have to specify the index, okay? The index, because it's got, you know, it's class 0, so it's the first row, and still it's a vector of 4. So basically, again, I end up, this is a vector of 4. The actual sample, F1, F2, F3, F4. This is a vector of 4, right? The means of F1, F2, F3, F4. So the operation results in a vector of 4. And then down here, the variances for class 0 is also a vector of 4, F1, F2, F3, F4 for the variances. So I can perform that division, right? So this vector is divided by this vector, and this one's just multiplied by 2 down here. So if you look at this, I encourage you to write this out as the equation. You will see that it's pretty much this equation over here, x minus mu squared divided by this. So we've got this part as the numerator. Okay, we've got that part figured out. Now we can do the same for the denominator, right? And the denominator should be even simpler. So it's np dot square root. And by the way, I could have just done all of this with a function. I just wanted to kind of, you know, write this out a little bit more. So here the square root is going to be of 2 times np for numpy dot pi. You guys know, oops, sorry, pi is 3.14 something, right? Pi, and then times all of that times, again, the variances, but of just the class that we are currently concerned about, you know, class 0, for instance. So IDX over there. Does this make sense, guys?
Yeah, it's making sense.
All right, and that's it. That's, you know, that gives you, that should give us the probabilities, right? That should give us the probabilities. This should return then a vector of 4, of the 4 posteriors there. Okay, so we have now 1, 2, 3, oh, sorry, we have 1, 2, 3, 4 in a vector. So I can go, let's go over here. So in, you know, if we're thinking about this, we've got, for each class, right? For each class, what is this thing doing? Class 0 and class 1. We've got the posteriors and the prior. Okay, and we've got them like this. So there are, you know, there's, you know, like 1, 2, 3, 4, and then there's 1, and then there's 1, 2, 3, 4, and we already got the probabilities in there. Now we just need to log we need to run all of these through log and sum them, and then multiply, or add them, sorry, not multiply, add them with each other, right? Because we said that we're making this little tweak, right? That we're going from multiplication to addition. So that's what we need to do. That's literally all that remains in our code. So we can, you know, we can pretty much wrap this up, I think. I've got the Gaussian set up, my PDF function. That one is explained. Now I just need to come back to my predict function, okay? So notice I took Gaussian here, you know, all the parameters that I needed. Notice we only needed means, variances, the sample, which we called X. Oh, by the way, XS is only used here, so that's good. Everything else should be fine. So we've got Gaussian, basically. We got our posterior vector. Okay. Okay, and now what we can do is we're going to do this posteriors for each class. Let's say posteriors per class, right? Per class. We only have 2 classes. We're going to store them there. So therefore, what do we need? We've got posterior here. That gives us, this should give us a vector returns vector of 4. And we've got the priorial already here. So what we need to do now is we need to take this result, posterior, And for that vector of 4, we want to run it to, so it's going to be posterior. We want to run this through the log first. So every one of the 4 values in the vector posterior will now be logged. So np.log. You see that? So this should still be a vector of 4, but now every individual value in there should be logged. That's great. And then finally, those 4 values in there, we just sum them. And we just do np sum here. And that's it. Now we've got these summed up. So we've got the 4 summed up, and now we just need to sum it with this one prior, which has already been logged. So then I can just do posterior equal, posterior. Let's just say prob per class, right? And now we just have to add it. So we have to add posterior plus prior. There you go. That is it. Now remember, this is done per class. We have 2 classes, therefore posteriors per class, or actually, I'm going to recall this results probs per class. See, actually, this one should be, what should I call this? Result, I guess. So for class, I think that works. Okay, and now the first iteration, I calculate everything for class 0. Next iteration, I calculate everything for class 1. We're almost done, guys. Almost done. So then all I have to do is result per class dot append. And what are we going to append? We're going to append the prob per class. So we have 2 in here. And that's it. We've got now the 2 classes, 0 or 1, and we just have to decide, okay, which one do we use? Well, we have to pick one of the 2, probably the highest value, right? Because remember, what we have in results per class now are probabilities, So we want to then do, the last part is return, and then we would do we want to return here the class with the highest probability. So return class with highest probability. Okay, so this should be out of result per class, right? Out of this, we need to pick, we're going to pick the index. We're going to pick the index by using NP argmax. I think we've already looked at this one in the numpy examples, or we will look at it. You can also just start working on those exercises on your own. But NP argmax is basically a function in Python that looks at something, right? It'll look at a vector of 2, 3 values, and it returns the index of the highest value. So if I have, let's say, 0.5, 0.3, 0.7, it'll return out of the 3. The last one is the highest. Therefore, if the indices are 0, 1, 2, it'll return 2. So this returns just the index of the highest value. And now I have the index. But I don't want the index, right? In this case, the index and the class align because it was 0, 0, 1, 1. But I could have had class -1, class 1, but the indices would have been 0 and 1. So therefore, just to kind of be more complete, out of the list of classes, you know, I will slice out the correct index. So that's all this does. And believe it or not, that is it. You have completed the numpy example. So hopefully, I haven't run this in a while. I'm hoping it doesn't give any errors, but that is the code. Okay, so this is numpy. So let's run it. I'm sure there will be some errors, but you know, we're almost at the end. The code is complete. I will double check this to make sure it runs. At least logically, I've explained everything. So definitely take a look at the video. I hope we were recording. Yeah, we were. So take a look at the video. So your homework assignment, obviously we have an exam next week. The exam will cover up until this next Tuesday or Monday, sorry. And otherwise, this homework is not due yet, obviously the naive Bayes. Take a look at the code, play with it, you know, understand it. And then I will, after the exam, I will kind of give you some details of what I want. But basically, you can expect, I want you to run iris and MNIST through this. But I think everything, and if there's any errors, I'll figure them out. And but I will load this Jupyter notebook probably in a little later today. So let's run it. Let's see what errors it gives us. Yeah, so there's some kind of error there. Okay, it's not callable. Results per class. Probably doesn't like that this is not a numpy, right? That's what I would guess. So what we can do, yeah, because this is just a straight up list. So let's do np.array. Okay, so now np argmax should apply to an array, a numpy array. So let's try that again. Nope. Do you guys see anything obvious? It's somewhere in here. It doesn't like. Doesn't like something in here. All right, so let's stop here for today. Work on this. I'm sure it's. You know, I'm pretty sure the code is correct. I will. Next class we will go over if there's any tweaks, and I will post obviously if I find what the issue is, because we're out of time. I'll just post this on Brightspace and on the GitHub, you know, so be on the lookout for that. All right, so let me save this and stop sharing.